So for section 2 of chapter 6, we're going to be solving systems algebraically using a method called substitution. And I have 5 steps here for how to do it. Step 1, we may not necessarily have to do because sometimes it'll be done for us. And it says solve for one variable in one equation. The key idea is when we do that, we're going to want to look for a variable that's essentially by itself already with no multiplier on it. I'll show you what I mean when we get to the examples. We will substitute what we get into the other equation. We will solve the new equation that only has one variable in it to get the value. We will take what we get and substitute back to an original equation, and we'll have ourselves an ordered pair. So let me show you how this kind of looks. In my first example here, I've got y equals 2x and y equals x plus 5. So you notice the left side of both of these says y equals. That's the same. Which means that this should be the same. I mean, y has to equal y, so 2x must equal x plus 5. Well, this is a two-step equation. Actually, it's a one-step equation. There's an x on each side of the equal sign. So I want to bring the smaller one to the other side. 2x take away 1x is x. And on this side, we're left with 5. So x is 5. We didn't need to solve for one variable in one equation because it was done for us. We did substitute. We solved. We know what x is. Now I need to take x and plug it back into either of the first two equations. It doesn't matter which. So I'm going to plug it back into y equals 2 times x, except for I know x is 5. And I think we can just go ahead and say that's 10. Which means the solution here is the ordered pair 5, 10. Okay, ordered pair solutions. We get an x, we get a y. We list x, y things as an ordered pair. In the second problem, the first equation doesn't say y equals, but the second does. So according to the second equation, I know that y is x plus 4. So I could rewrite the first equation, 2x plus, but instead of putting y in, I'm going to put what y is equal to, which is x plus 4. And that equals 5. I have like terms here, so combine those. 3x plus 4 equals 5. And finish solving. I'm going to get, subtract 4 from each side, I get 3x equals 1. Divide both sides by 3. X is equal to a third. I do have to plug that back in. So I'm going to plug it into the bottom equation that says y equals. So y equals 1/3 plus 4, which is, let me break this off as best I can, which means y equals 4 and 1/3. So the solution is the ordered pair 1/3, 4 and 1/3. All right. Let me move this along. And probably ought to give myself a little more room to work here. And by a little more room, I mean, let's just go ahead and put that onto its own page. There we go. Lots of room to work now. And let's try to split this roughly in half so that I have space to work. All right. Now, neither one of these equations say x equals or y equals, which is unfortunate. What we want to do is pick one of the equations and solve it for one of the variables, my first step. The key thing to look at here is find yourself a variable that has a coefficient of 1. So that would be this x or this x, or this y. It doesn't really matter which one. For a change of pace, I'm going to get this x by itself. So I'm going to take that second equation. I'm going to subtract y from each side and get x equals 3 minus y. I have an expression for x that I can take and plug back into, oops. I'm going to take this and put it back into the first equation. I solve the second, I have to plug it into the first. So the first equation says x. Well, x isn't x anymore, it's 3 minus y. And then we have plus 4y equals 6. So there are like terms here, the negative y and the 4y. Those are like terms, so let's combine them. Negative y plus 4y is positive 3y. And now it's a two-step equation. Subtract 3 from each side to get 3y is equal to 3. Divide both sides by 3 to get y equals 1. Now we need to plug this back in somewhere to get x. Maybe better color. There we go. Now, I say you have to use one of the original equations, so we could use this, but we can also use an equation we manipulated to obtain. So I'm going to use this one that says x equals, because I want to know what x is. So if I have an equation that says x equals 3 minus y, and y is 1, then x is equal to 2. And the ordered pair is 2, negative 3. For the next example, we have 2x plus y equals negative 4, and x plus y equals 7. Again, it does not make a slightest bit of difference which variable you want to get by itself. I just recommend doing one that's already got a coefficient of 1. So let's do this x. Let's get that x by itself. So if I have x plus y equals negative 7, and I want the x by itself, I need to move the y. So we will subtract y from each side and get x equals negative 7 minus y. And I don't know why. There we go, my negative 7. I've got to take this now and plug it in for x in my first equation. My first equation says 2x. So I have to do 2 times the whole thing of negative 7 minus y. Then I can finish off with the plus y equals negative 4. I must distribute. I have to take this 2 and multiply it to both the negative 7 and the negative y in parentheses. 2 times negative 7 is negative 14. 2 times negative y is negative 2y. And the plus y equals negative 4 hasn't changed yet. There are like terms. These are both y's, and they're on the same side of an equal sign, so they need combined. That negative 14 is still negative 14. Negative 2y plus 1y is now negative 1y. And now it's a two-step equation. Add 14 to both sides to get negative y equals 10. And divide both sides by negative 1 to get y is equal to negative 10. Again, we got to plug this into an equation. And again, I'm going to use the one that already says x equals. I have x equals negative 7 minus y, but y is negative 10. That's an equal sign. X is equal to negative 7 plus 10, minus a negative means to add. And x is equal to positive 3 when we combine those, which means the ordered pair is 3, negative 10 for the solution. I should probably turn autosave off because I don't want it saving this. And it did it already anyway. Oh well. I'll have to go back and delete all this. Not a problem. Alright. So for the next example, 4y minus 5x is equal to 9, and x minus 4y equals 11. There is basically one choice for which variable you want to get by itself. Because this x that I just highlighted is the... Oops. I did highlight it, didn't I? We're doing this, aren't we? Okay. Give me a second. It should calm it down now. This x is by itself. And when I say by itself, I mean it has a coefficient of 1. So I'm going to take the second equation, x minus 4y equals 11. I'm going to solve it for x, which means I'm going to add 4y to each side. I'm going to have x is equal to 11 plus 4y. I now plug this back into the first equation. So 4y minus 5x. Well, x is 11 plus 4y for us right now. And that whole thing is equal to 9. Distribute. So 4y stays 4y. Negative 5 times 11 is negative 55. Negative 5 times positive 4y is negative 20y. That equals 9. There are like terms. These two things have the same letter on the same side, so I should combine them. That's negative 16y minus 55 equals 9. And now it's a two-stepper. Add 55 to both sides. So the negative 16y is equal to 64. Divide both sides by negative 16 to get y equals negative 4. And again, we got to take this and plug it back in so we can get x somewhere. And I'm going to plug it into the x equals. So let me swap over here. X equals 11 plus 4 instead of y times negative 4. 4 times negative 4 is negative 16, so I probably shouldn't put a plus sign there. And 11 minus 16 is negative 5. So the ordered pair solution for this example is negative 5, negative 4. And then let me get rid of all this because I'm going to need the space back. The last example, take a look at those two equations. Which variable and which equation should I be getting by itself? And I hope you said the y in the first equation because it has the coefficient of 1. So I'm going to take that first equation of negative 2x plus y equals 8. I'm going to add 2x to each side so that we get y is equal to 8 plus 2x. I solved the first equation, which means I have to plug this into the second equation. So that's going to say 3x plus 2 times the quantity 8 plus 2x equals 9. Distribute. So 3x stays. 2 times 8 is 16. 2 times 2x is 4x. I have two things that have x on the same side, so I should combine those. So I get 7x plus 16 equals 9. I will subtract 16 from each side so that 7x is equal to negative 7. Divide both sides by 7 to find out that x is negative 1. And then I'm going to take that negative 1 and plug it back into the equation that says y equals. So no longer y plus 2x, but y plus 2 times negative 1. That's 8 minus 2 That is 6. That means the ordered pair is -1, +6. Now, a lot of you may be asking yourselves, okay, I'm going to have to write a lot of work, which, yes, you are. What if we continue to be out for a long time? How am I going to ever take a quiz? Well, I've got a bit of a solution for that. And a way that you can do things where I can leave comments. So let me clean this up. Which means I need to get rid of all this. Actually, I'll come back and do that. So what I'm going to do is pop back up here because I'm going to need to see some of these equations. And I'm going to find my Google Docs. And I'm going to make myself a new one. Yeah, new document, please. Please enter a name. Let's see. We'll just call it examples. Without an E. Perfect. Okay, so if this were an assignment, you would put your name, you would put Algebra 1, not Algebra Q, Algebra 1, not Algebra Q, Algebra 1, and you'd put the actual assignment. And then you'd put like number 1, but this is going to be example 1 because it's the first example from the notes. What I think the easiest thing to do here is going to be to insert, which is, I believe, the plus icon, and a table. And we're going to want 2 columns, and we can go with however many rows. We'll add more as we need. So in the first column here, I'm going to put the example. So the first example was y equals 2x and y equals x plus 5. So actually give me 1 second, I'm going to snap my keyboard back on because it'll be a lot faster for me to type this than to poke at the iPad screen. Okay, so y equals 2x and y equals x plus 5. So here are the equations. Quit making that capital. Seriously, whatever. So because y and y are the same thing, I can go straight to substituting. Substitute. So back in the first example, we said, okay, the 2 y's are the same thing, so 2x must be equal to x plus 5. From here, I said, okay, we need to move the smallest x over, so we subtract x from each side. That got us x equals 5. Which was fine, but then we had to plug it back in somewhere. So, if you tap on the bottom right corner of the table, right here, you should get a bunch of options, but none of these are what I want. I want to... Oh, that's right, it's at the top. Okay, so you get the blue cell around. You get a whole new set of options here on the right side. And there's this icon over here with a plus sign at the bottom. That is add row. Boom, add row. And I think I'm going to need like 2 or 3 more. So I'm just going to give myself a few more. You could also just give yourself a bunch to start with and then delete the ones you don't use. So now, no, calm down. Okay, there we go. So I know x is 5. I'm going to take it and plug it back into either of the first equations. And at this point, I don't really need you to tell me that you're multiplying. I know that's what you're doing. So there's a quick example of how to do this using Google Doc. I'm not going to do all 6 examples, but I will go and do, how about the last one, since it's probably the biggest pain in the butt. So let's see. This is example 6. And I need myself a table with 2 columns, and quite frankly, I'm probably going to need a bunch of rows, so let's go with like 12. That might be overkill, but there's no good kill like overkill. So negative 2x plus y equals 8. Negative 2x plus y equals 8. And 3x plus 2y equals 9. So 3x plus 2y equals 9. So what I'm going to do is I'm going to solve first equation for y by adding 2x to each side. Okay. Yes, I'm combining a couple of things that I did in the notes, but that is purely for my own sanity. Okay, so that would get me y equals 2x plus 8. And I will now substitute this for y in the second equation. So my second equation is going to be 3x plus 2, but instead of y, we'll have 2x plus 8. That equals 9. At this point, we had to distribute the 2. That got me 3x plus 4x plus 16 equals 9. We had to combine like terms. That got me 7x plus 16 equals 9. We subtract 16 from both sides. That gets me 7x equals negative 7. And we divide both sides by 7, so that x is equal to negative 1. And then we need to take this and plug this into the y equals equation above. Again, I need to know y, so why not use the one that says y equals? So 2 times negative 1 plus 8. And again, once you're to this point where you're doing y equals, I don't need you to tell me exactly what you're doing. And it's entirely up to you if you want to show this level of work, because I would expect you can, manipulate this in your head. But we do need to remember to include the final answers in repair. And I wound up with a row I didn't need, so I can tap on the outside edge, and then I can hit delete row. It goes away, and there is the table with exactly what I need in it.